Let us add another step or two to the problem of solving equations. Here we have some examples that are going to involve more than just one step, thus multi-step equations. But the process is still the same. So take a look at this first problem right here. I need to solve for x. Let's see. What's keeping x from being by itself? Well, one problem I have is that I have x in a couple different spots. I also have this subtract 2 that's keeping x from being by itself. So let's rewrite any subtraction in this problem as addition, because I told you how much I think that's important. So let's rewrite this problem as negative 5x, subtract 2 becomes an add negative 2. I have an add 3x equals to 1. Now, you know what? I have two like terms here. This negative 5x and this positive 3x are like terms, and so I can combine them. And that will take care of one of my problems. When I'm combining them, I'm going to write them right next to each other so you can see me doing that. I'm just rewriting my problem here. Just use the commutative property to move this 3x over next to the 5x. A negative 5x, and I'm adding 3x to it. They're like terms, so I just add their coefficients. Remember, coefficients are the number out in front of the letter. A negative 5 and a positive 3 make, I'm moving right up here, a negative 2x. So a negative 5x and a positive 3x made a negative 2x. I still have the rest of my problem here. I need to keep moving to get x by itself. What is keeping x by itself? Okay, there's a couple things keeping x by itself. I have a negative 2 hooked right next to the x right there. I also have a negative 2 over here. You have to get rid of the right number first. Okay, only one of these you get rid of first, you'll get the right answer. If you do it in the wrong order, you'll get the wrong answer. So here's one way to think about it. Okay. I look at kind of proximity to x. Do you see this right here? This negative 2 is hooked right to the x. It looks a little bit easier to get rid of this one first, and it is. Okay, so I'm going to get rid of this negative 2. I can get rid of a negative 2 by adding 2 to each side. Rewrite my problem, negative 2x, this made 0, equals a positive 3. Now I can get to the x right here. This x and this negative 2 are hooked by multiplication. I can undo multiplication with division. I can get rid of a multiply by negative 2 by dividing by negative 2 on both sides. That makes 1, and I'm left with just plain x equals negative 3 halves. I want to go back up here to where my problem looked like this. I'm going to rewrite it. I'm going to give you a little analogy that I tell students. I'm just going to erase all this. If I want to get x by itself, and looks like there's lots of steps in here to get x by itself, I kind of liken it to taking off your socks and shoes. If you want to take off your shoes, you need to take off your socks. If you want to take off your socks, you need to take off your shoes first. First shoes, then socks, and you kind of work your way in. Okay? If I want to get to this x, first I need to take care of this, and then I can work my way closer to x. So hopefully you understood that analogy. It works a little better if I'm standing in front of you in person and I can describe it. You'll just have to imagine. Okay? So we solved that problem. Let's move on to this next one. Okay, again, these are looking quite a bit more complicated, but we'll work through this process. The whole thing is I want to get k by itself. Well, before I can get k by itself, I need to do some simplification. I've got a subtract here. We could change that to an add, negative. I've got something I need to distribute here. Let's do all of those steps together. So I have 2k. This subtract one, I'm going to change it into an add, negative 1. Then I'm going to take this 3 and I'm going to distribute it using multiplication to each piece on the inside. So I'm left with a 3k. I took 3 times the k, and an add, that came from right here, guys. And then I take the 3 times the 2. And I still have my equals 4. Let's go through and do a little more simplification. 2k, add negative 1, plus 3k. I'm just rewriting on that part. 3 times 2 is 6. Okay, now I can look for any like terms that I can combine. 2 2k and 3k are like terms, and -1 and 6 over here are like terms. I'm also going to be able to combine them over here, but let's wait on that for a second. 2k and 3k, when I add them together, I can get a 5k. A -1 and a +6, when I add them together, I get a +5. And I still have my 4 over here. Let's move my problem up here. I'm just going to rewrite it. 5k plus 5 equals 4. I need to get k by itself. I've got this 5 here is keeping k by itself, and this 5 right here is keeping k from being by itself. Which one do I get rid of first? You know, it's just coincidence as both these problems that I've made up for you, I've had the same number here. That's just coincidence. Don't let that bug you. I'm going to have to get rid of this one first. I can get rid of this add 5 by subtracting 5. To both sides, keep it even. I'm left with 5k, 5 subtract 5 made 0, equals 4 subtract 5 is -1. Now I can get rid of this 5. This 5 is hooked by multiplication. I can undo multiplication using division. I can get rid of a multiply by 5 by dividing by 5. Again, do it to both sides. 5 over 5 makes 1. I'm left with k equals -1/5. Okay. I'm going to skip. This next problem is very much like the two above it. I'm just going to give you this very last example here. Right here. That's the one we're going to work on. Okay, so we're going to take a look at 6x minus 4, the quantity 6x minus 4 over 3, subtract 2 equals -5. I have a few things keeping x from being by itself. I've got this, I've got this, I've got this, I've got this. That's a lot of numbers keeping x from being by itself, but we will work our way through one by one. What do you think the first thing you need to do is to get rid of? Right here, you need to get rid of this subtract 2. See how it's kind of farthest away from the x here? We can get rid of the subtract 2 by adding 2. I'm going to rewrite this. Something about my equation editor, it keeps changing the size of those numbers, and it's bothering me. So here I am rewriting my problem. Okay, so we are going to add 2 to both sides. Rewrite our problem. I'm left with 6x minus 4 over 3. Subtract 2 and add 2 makes 0 equals -3. Okay, now I still need to work to get x by itself. I can choose to get rid of, you can choose only one's the right answer, the 3, the subtract 4, or the 6. Okay, when you're choosing what to get rid of, you're actually having to work in opposite of order of operations. You know, in order of operations, we always did addition and subtraction last. Notice when we are undoing, we actually undid addition and subtraction first. Okay, so now I'm going to undo some multiplication and division. You say, oh, there's some subtraction up here, but remember when I said when things are on top of a division bar, it's like being in a parentheses, and parentheses is one of the last things that we undo because we're going opposite of order of operations. So that's why I'm going to get rid of this divide by 3 first. So the way to get rid of a divide by 3 is by multiplying by 3. Do it to both sides, be fair. 3 on top and 3 on bottom make 1. I'm left with 6x subtract 4 equals -3 times 3, which is -9. Okay, now I'm going to keep working to get x by itself. I am going to undo subtraction before I undo multiplication because we're going in opposite of order of operations here. So I will get rid of the subtract 4 by adding 4. I'm left with 6x equals -5. Now I can undo this multiply by 6 with a divide by 6. 6 over 6 makes 1, and I am left with x equals -5/6. You could see those weren't just one-step or two-step equations. Those were 3, 4, and 5 steps to solve the equation. But the process is still the same. We work through by undoing. We undo subtraction with addition. We undo multiplication with division. We undo division with multiplication. We undo to get the variable by itself. And sometimes you have to do a little bit of combining like terms. If you end up with any like terms, we didn't do this problem, but we would end up with like terms if we worked through this one. And that's how we solve these equations.